this video, I'm going to solve practice problems on instantaneous acceleration. And as a quick reminder, in previous video we talked about instantaneous velocity, which is the derivative of displacement with respect to time, this formula. And then in other videos we talked about instantaneous acceleration, which is the derivative of velocity with respect to time, which can be simplified as the second derivative of displacement with respect to time, which is all of this. So in other words, if you have the displacement, you can find velocity by obtaining the derivative, and by obtaining the second derivative, you find the acceleration for that displacement. And that's what we're going to do in this video. We're going to do a complete analysis. Okay, so let's say our displacement, xt, or x, is going to be 3 centimeters, 0, minus 0.3 centimeters per second squared times time squared. If this seems weird, you can think of this as y is equal to 3 minus 0.3 x squared, which this is y of x. And if you understand how to obtain a derivative, this may seem simpler. In this case, we're just using units. So what we want to find is the velocity and the instantaneous acceleration. And well, we can do that by obtaining two derivatives. The first one being the velocity, and the second one being the acceleration. Let's first find the velocity. So v of x is going to be the derivative of displacement with respect to time. So that is going to be, the first term is a constant, so that becomes 0, minus the second term. You have to use the power function because t is squared, that is our variable. So it will be 2 times 0.3 centimeters per second squared and times time. And that ends up being velocity is equal to negative 0.6 centimeters second squared times time. That is our first part. The second factor asks for the acceleration, which is simply the second derivative of displacement, or the derivative of velocity. So we can obtain the derivative of this factor, which is 0.6 centimeters per second squared. So what happened is, because we had a constant times a variable, all you get is a constant. In other words, this time becomes 1. We could even expand this a little further by asking for what the speed is, so that's just the absolute value, and assigning values to the time. Let's do that in the next page. So those were the results we obtained. We want the speed, so that's simply obtaining the absolute value of the instantaneous velocity. So it would be 0.6 times time, which is 0.6 centimeters squared times time. So it goes from negative to positive. That is the speed. Now let's say that the time has a value of 8 seconds. And now we want the assigned velocity and acceleration. So because we already obtained these two factors, these two equations, we can simply just plug in the time. So velocity would be equal to 0.6 times 8, and that becomes negative 4.8 centimeters per second, because the time would be 8 seconds, so this would cancel with one of the times. And for the acceleration, AX, that would be negative 0.6 centimeters per second squared. So there's no change for acceleration, because as you can see, there is no time factor in here, so you can just omit it. And that is all I wanted to cover in this video. Thank you for watching this video. I hope you liked it and found it useful, and if you did, please be sure to give it a like and subscribe to see more videos like this one.